So you compute like precision and recall, and then you create a plot which is called like precision recall over precision. I will show that plot later, which is actually useful to compare different algorithms. Now, a good edge detection algorithm will actually find all the real edges, all right, and it will try to ignore noise and other artifacts. And not only that, it should also try to localize it well. So what I mean by that, for example, this is a true edge, and your method is giving something like this. So it's not like localizing it well, although it's detecting edges, but it's not localized, right? Again, this is like slightly better, but again, the locations are not correct. And in this case, you can see like this bar over here, if this is representing the red one, then it's actually giving you the correct edge, but it's kind of too many responses, right? So it's over predicting. Now, looking back at precision and recall, in this case, you might get a good precision because it could be like 3 of these are correct and 2 are incorrect. So the precision will be 3 over 5. In this case, let's say this is the correct edge. So in this case, the precision is actually better than this. The precision will be 2 over 4 because these 2 are correct and the total are 4, which the method predicted, right? And again, you can compute recall as well. So if you look at recall will be best for this method because it's actually detecting all the edges, right? But if you look at the precision is going to be pretty bad because it's predicting like these 3 and these 3, 6 extra edges, which were not there in the ground truth. All right, so that gives you a sense of what precision and recall means when you perform edge detection. Now, what you do is you have that recall, you have that precision, and you vary your threshold, which is like kind of saying this is an edge or not. So you will have that threshold. So if you vary that, then eventually like you can get this kind of curve. And the idea here is if you have like a very high threshold, which means you are predicting very few edges. So recall is 0. In that case, I mean, if you're predicting few, of course, your precision should be high, right? Because if let's say you're not predicting anything, it's 0, then your precision is kind of, you can say like perfect. You are never wrong. Okay, so that's why the curve starts from the top here. And then as you lower the threshold, which means that you are trying to predict more edges, so some of them will be wrong, then your precision will fall. But since you're collecting more edges, your recall is going to improve. And eventually, if you say like, you say the whole image is an edge, then your recall will be perfect, 100%. But then your precision will go down because most of them will be wrong. Okay, so that's how this curve is plotted. And these are like methods. Some of these algorithms we are going to discuss. The green dot over here, that's like human level performance. And these are various algorithms. We are going to start with Privet and Sobel, which are right here. You can see like around 68 and 70, right? 1968, so 30, 40 years back. And you might say that, okay, this is like, we will study later, like almost a similar kind of algorithm, but with a gap of 2 years. So for today, that seems weird. But if you think about like how it used to be worked like back then, we didn't have internet, anything, right? So you performed some research, then you had to mail like that paper. Even printing was not possible. Sometimes it's like handwritten notes. So just communicating your research was like a year-long process, even more than that. So it might happen that both the researchers were not aware of like each other's work. But today it's like you did something, you just publish online, it's out there, right, immediately. So it's quite different, which is actually good.